Hey everyone. In this video, we're going to take a look at how to rationalize an expression using the complex conjugate of its denominator. Okay, so here we see we have a complex expression as our denominator, which again, we can't have an imaginary number in our denominator. So what we're going to do here is we're going to multiply both the numerator and denominator by the complex conjugate of our denominator. Now, we learned in the last video that the complex conjugate has the same terms as your initial, but we change the sign. So here we have a 4 minus 3i, so it becomes a 4 plus 3i. And again, the reason we're multiplying by the conjugate is, again, we learned in the last video, that when you multiply a complex number times its conjugate, it becomes a real number, which is what we need to have in our denominator. Okay, so let's go ahead and do that. Okay, so on the top, it's just distributive property. 3 times 4, that's going to give me 12. And then 3 times 3i is going to give me a 9i. And in the denominator, we're multiplying a complex conjugate times, well, we're multiplying a complex expression times the complex conjugate. So we just need to square both of our terms. So we're going to have 4 squared, and then our b is 3, so it's going to be plus 3 squared. And again, we reviewed that in the last video, so if you need to take a look at that, you can feel free to do so. All right, so the numerator is going to be 12 plus 9i. And then the denominator, we're going to have 16 plus 9. Continue to simplify, still 12 plus 9i. Over 25, and now we'll split it and write our final answer. So it's going to be 12 over 25 as our real part, plus 9i over 25 as our imaginary part. And that would be your final answer. Again, notice all real numbers in our denominator. All right, let's take a look at one more. Okay, so here we have an imaginary number in both the numerator and denominator, but again, we just care about getting this imaginary number out of our denominator. So we have 4 plus 3i, going to multiply by the conjugate, which would be 4 minus 3i, and again, you need to do that on top and bottom, both the numerator and denominator. And we'll go ahead and do the same. We're going to distribute here, so we get negative 5i times 4, that's going to be a negative 20i. Negative 5 times negative 3i is going to give me a positive 15i squared all over. Again, multiplying by the conjugate, you're just adding each of your terms squared, so it's going to be 4 squared plus 3 squared. And again, I'm getting that from our terms. Okay, so next, we're going to start simplifying this. We get a negative 20i. 15i squared, we know from some of our prior videos that an I squared becomes a negative 1. So that's going to be like having a minus 15. 15 times negative 1 is negative 15. And then in our denominator, 4 squared plus 3 squared, that's going to be 16 plus 9, which is going to give me a 25. All right, let's continue to simplify this. Okay, so we can split them. We'll go negative 15 over 25, I'll put the real part first, and then our imaginary part 20i over 25 after. And then we'll simplify. Negative 15 over 25, we can divide both of those by 5, in which case you would get negative 3 over 5. Minus, and then 20 over 25, again divide both of those by 5, and you would get 4i over 5. And there's your solution. Okay, so again, if you have a complex number with both a real and imaginary part in your denominator, you can multiply by the complex conjugate to make that become a real number, and then you're just simplifying your expression.